Okay, so we've created arrays and these matrices in several different ways, and that's great, but we need to be able to use these arrays. And first and foremost, we need to be able to address the elements in the array, find out their address, go get that information, and use it in our mathematical calculations. The elements in an array can be addressed individually or in subgroups, and we do this using something called subscript notation. And so the subscript is going to come from the idea that each of the elements in a matrix are numbered. And what I mean by this is that if we have a row or a column matrix, B, then the address of each of the elements is going to be I, which can be any number that's there. So if it's going to be the first element in B, this would be B sub 1. If it's going to be the fifth element, it would be B sub 5. The 74th element would be B sub 74. And then this A sub ij indicates that we now have two indices that we're working with that are stored as subscripts, or that we show them as subscripts. And we read this as A sub ij would be the ith row and the jth column. So if we want an element from the 6th row and the 12th column, it would be A6, 12. And in MATLAB, we implement this subscript notation simply by using the left and right parenthesis near the matrix that we have. So let's take that years column that we had earlier, and if we want the second element of the years column, then we'll say years column, and then we'll put the 2 in parenthesis. Now you can see that it's storing this as ANS, meaning that it's assigning this value 2020 to the variable ANS. We can always store this as the year I want as some other name is equal to our years column 2. And this way of calling a particular element using a single number in parentheses is going to work for either your row matrices or your column matrices. It'll also work for your two-dimensional matrices. However, I recommend that you don't use a single number for that. Instead, we want to use two numbers that mirror the subscript notation that we showed earlier with the ij. So let's apply that subscript notation using the ij to our Denver population table. So here's our table, and let's just say we want to get the first row, second column, which should give us 2.86, or maybe we want to get the third row, first column. We're now giving it the open parenthesis, our first element, our first argument is going to be the row, our second argument is going to be the column. Now this same subscript notation in MATLAB is going to work for rewriting an element of the table. So let's just say that we messed up and this value actually should be 2.76 instead of 2.79. There's no reason to then go to the table and recreate that entire table again. Let's just change Denver population table. This is our third row, our second column is the one that we want to change. And we're going to use our assignment operator to assign 2.76 to this element in Denver population table. And you can see that the output has just replaced our 2.79 with 2.76. The last thing that we need to cover is to look at how we can pull in the colon operator when addressing arrays. So let's go back to calling these individual elements in a one-dimensional column array. So let's look at our population column. And in our population column, we said we can address a single element by putting it into the parentheses. But if we want to pull two elements out of this, let's say we want the first one and the third one, we do that, interestingly, by putting in another array as the argument. So we're saying give me the first element and also give me the third element, and that should give me 2.86 and 2.79. And it's storing it in its own 2x1 matrix. And you can see this over in the workspace, 2.86, and it has a semicolon 2.79. And we can make a similar command if we want two of these that are side by side. So it's the second element and the third element. And this is where we can use the colon operator. And instead of saying population column 2 and 3 in a matrix with the square brackets, we can use the colon operator, which is 2 colon 3, which is also a matrix similar to what we would use with the square brackets. And we get its own column matrix, 2.83, 2.79, that is indexing now the second and the third portions of population column. And we can do this same colon operator to address a range of elements within a matrix. So for our Denver population table, let's take the first 2 rows of the first column. And so for those first 2 rows, I'm going to address it this way. So remember, we're going to do our rows first, and that would be 1 colon 2, and then of our first column, and that gives me the 2021 and 2020. And most of the time, you're probably going to be addressing an entire column, taking it out, or an entire row and taking it out from the table. So to do that for a Denver population table, instead of giving it a starting point and an ending point, then we would address that using just the colon. So this says, give me all the rows in the first column, or we can say all the rows in the second column. And if we change our mind or have another need to take one row, the first row, and give me all the columns, then we put the colon operator in the columns place. All right, so this concludes our introduction to how to create and address numeric arrays. And as I mentioned earlier, in MATLAB, this is the heart and soul of the program. This is primarily what we'll be doing as we start to build our numerical methods in this course. And then it's also what most of the built-in functions are using. So most of the inputs are going to be arrays. And so you'll have an opportunity to explore lots of the help menus. I encourage you to do that. I encourage you to take a look at the cheat sheet that we have for creating and addressing these arrays. This is going to give you some helpful tools for understanding the syntax, and then also just some notes through there to help you do this more efficiently.